We just talked about regression, where we're trying to predict real-world numbers, real-valued numbers. The other big category of supervised learning is classification, where we're not predicting numbers, but rather we're predicting categories. For example, we might have input data consisting of an image. We apply some sort of classification method, and our output might either be the category cat or the category dog, if we're trying to predict cats versus dogs. But in classification, we have to output some sort of number. We can't output a string that says cat or a string that says dog, because we can't learn some function that's going to output the string cat or dog. If you know some mathematical function that can output a string for a category and make sense with parameters, then let me know. But I've never heard of that. So instead, what we need to do is to output a probability of each class. So in binary classification, where we're predicting dog versus cat, then the output of the classifier might be 84% probability of dog and 16% probability of cat. So that is the type of math we're doing. We're given input, and in the case of image classification, which we'll have a separate mini course on, the input represents a matrix of pixels, so that's the mathematical representation, and the output is a probability vector of each class. But let's go into more simpler terms, and I'll move my video over here. So let's say that we have data, we're trying to build a classifier to predict two categories, overweight and not overweight. And the two input variables that we have are each person's hours of exercise per day, x1, and the calories consumed by that individual per day, x2. And we plot each individual on this two-dimensional plot, and we plot them as a circle if they're overweight, and we plot them as a square if they're not overweight. The goal of classification, the mathematical goal, is to find the line or shape that best separates these two categories. For example, this line, which clearly distinguishes overweight from not overweight. And so if we learn this line and we get new unknown data points, for example, these question marks, then we can classify the points given the hours of exercise per day and the calories consumed per day. We can plot them and classify them based on which side of the line they fall. So if they fall on the side of the line where all the circles were, we predict it as circle. And if they fall on the side of the line where all the squares were, then we predict it as square. So that's how we do classification given a classifier that's learned a shape that best separates the points. But the mathematical goal of classification is how do we learn this separating shape, which doesn't have to be a line. In some types of classification, it has to be a line, but in other types of classification, it can be a curve or some complex shape. So that is the intuition behind classification.